Hello students, welcome to Saurav Sir's classes. This video is Time and Work Part 2. From the previous video, we can say that efficiency is inversely proportional to time or the number of time units Therefore, efficiency into time is equals to constant work. The whole work is always considered as one. Whole work is always considered as 1 when it is stated in terms of fraction and 100% when taken in terms of percentage. In general, the number of days or hours taken to finish the work is given by 100 divided by efficiency. Next, we will study about some of the important formulas that can be useful to solve the problems regarding time and work. The first one being, suppose A can do a work in X days and B can do the same work in Y days, then time taken by both A and B to finish the work together is equals to the time taken by both A and B to finish the work together is equals to X into Y divided by X plus Y days. In next formula, we have that if A can finish the work in X days and A and B together can finish the work in Y days, then B will finish the work in, or B can finish the work in X into Y divided by X minus Y days. So this is the time taken by B to finish the work. Next, if A, B and C are three persons who can finish a piece of work in X, Y and Z days respectively, then together they will finish the work in X into Y into Z divided by XY plus YZ plus XZ days. That is, A, B and C will finish the work together in XYZ divided by XY plus YZ plus XZ days. In general, if A1 takes X1 days to finish a work, A2 takes X2 days, so on till AN takes XN days to finish a certain work, then this means that A1's 1 day work is 1 by x1, A2's 1 day work is 1 by x2 so on till AN's 1 day work is 1 by xn. So 1 day work of A1, A2 so on till AN altogether is 1 by x1 plus 1 by x2 plus so on till 1 by xn. So A1, A2 so on till AN will take 1 divided by 1 by 1 plus x1, 1 by x2 plus so on till 1 by xn, this many days. So when A1, A2 so on till AN will work together, they will take this many days to finish the work. Now, if A and B can finish the work in X days, B and C can finish the work in Y days, and A and C together can finish the work in Z days, then if A, B and C works together, they will finish the work in 2 into X into Y into Z divided by XY plus YZ plus XZ days. In the next formula, we have A and B who can finish the work in A and B days respectively. Now, both begin to work, but after some days A leaves and the remaining work is completed by B in X days. Then the time after which A left the work is given by, let us denote the time by T, then T is equals to B minus X into A divided by A plus B. We often encounter questions based on work and wages. Now we have to understand that wages is directly proportional to the amount of work done. It means that the person will earn more money if the amount of work done by him is more. Therefore, wages is directly proportional to efficiency and inversely proportional to the time taken by the person to finish the work. Now suppose A, B and C can finish the work in 60, 45 and 30 days respectively. Therefore, the ratio of their share of work or the ratio of their wages would be 1 by 60 is to 1 by 45 is to 1 by 30, which is equals to 3 is to 4 is to 6. So if the total amount to be distributed is given, then with the help of this ratio we can find the amount earned by each individual. The next type of problems we encounter is the problems based on pipes and cistern. It works in similar way as before, that is, if pipe A can fill in H1 hours and pipe B can fill the tank in H2 hours, then both can fill the tank in H1 into H2 divided by H1 plus H2 hours. However, in this case, not every pipes fill the tank. Some of the pipes can also be present that instead of filling, empties the pipe. For example, if there is a pipe A that can fill the tank in say H1 hours, and pipe B can empty the tank in H2 hours, then the time taken to fill the tank when both A and B are working together is given by H1 into H2 divided by H2 minus H1 hours. Here H2 is greater than H1. Now H1 cannot be greater than H2 because if it is the case, then the tank will never be filled if both the pipes are working together. So H2 is greater than H1, then the time taken to fill the tank is given by H1 into H2 divided by H2 minus H1 hours. Now suppose we have two groups such that M1 person of first group completes W1 work in D1 days working H1 hours per day, and M2 person of second group completes W2 work in D2 days working H2 hours per day. Then we will have the following equation where M1 into D1 into H1 divided by W1 is equals to M2 into D2 into H2 divided by W2. Now if both the groups completes equal amount of work, then we will have our W1. If equal amount of work that is our W1 is equals to W2, then we will have the equation M1 into D1 into H1 is equals to M2 into D2 into H2. Here we are assuming that each person in both the groups have same efficiency of work. Next is relationship between efficiencies. Now suppose 12 boys can do a work in 3 days and 3 men can complete the same work in 4 days. Hence, it means that we need 12 into 3, that is 36 boy days, and 3 into 4, that is equals to 12 man days to finish the work. This implies 12 men can finish the work in 1 day, whereas 36 boys would be needed to finish the work in 1 day. This implies one man is as efficient as 3 boys. Hence, we can say that a man is thrice efficient as a boy, or a man is 2 times more efficient than a boy. So this is the relationship between the efficiencies.